Hello guys, welcome back to our channel. Today we are going to discuss about what is the NAND latch and how to make the Verilog code for this NAND latch. So for that we require two NAND gates. Two NAND gates. NAND is nothing but the complement to the AND gate, right? And one of the input will be the S, and other of the input will be R, and the second input of the both gates will be cross connected to each other. Okay, here I am naming the output as a Q and the Q bar. Okay, so we are going to develop the truth table for this. So S, R, Q and the Q bar, right? So here what are the possible combinations? 0 0 0 1 1 0 and the 1 1. Before developing the truth table of the NAND latch, just we recall the truth table of the NAND truth table so that we can easily develop the NAND latch truth table. Okay, so for that I am taking the inputs as a comma b, and I am writing the 0 0 0 1 1 0 1 1. Okay, here the output will be 1 1 1 and the 0. Here the expression of the NAND gate is nothing but the y equal to a b bar. So that means 0 into 0 0 and the complement to the 0 is 1. So in this way the truth table will be developed for the NAND gate. So based on this we will develop the NAND latch truth table. Okay, so initially I am taking as a S equal to 0 and the R equal to 0. Now we have to obtain the Q equal to and the Q bar equal to, right? So I am applying the here I am giving the S equal to 0 and the R equal to 0. S 0 into Q bar 0 and the complement to the 0 is nothing but 1, and here this 1 will be given to this R. So 1 into 0, here 1 into 0 output will be 1. In the latch the Q and the Q bar must be complement to each other, but here you can see that the Q and the Q bar are same. This is not possible in the latch, so what we call the state as invalid state. Okay, invalid state. Next, S equal to 0 and the R equal to 1. Again same procedure. Now I am giving the input as 0 and the 1, right? So 0 into Q bar 0 and the complement to the 0 is 1. Okay, now this 1 will be given to the second input of the R NAND gate. So 1 into 1 the output is 0. So here Q is 1 and the R is 0. Okay, here Q is 1 and the R is 0. Next, if we apply the input as S equal to 1 and the R equal to 0, right? S equal to 1 and R equal to 0. Here we cannot perform 1 into Q bar, because if the one of the input is 1, next based on the second input the output will be decided. But if the first input is 0, we can easily determine the output of the gate. So here I am considering here as 0 0 into Q 0 and the complement will be 1, and this 1 will be redirected to the this, and what are the input we have given? So here 1 1 is given, so 1 into 1 1 and the complement is nothing but the 0. So here the Q is 0 and the Q bar is 1. Okay, here Q is 0 and the Q bar is 1, and the final inputs are given S equal to 1 and the R equal to 1. Now suppose if you have the previous state as the 1, now it is applied to this 1 into 1 1 and the complement will be 0, and these 0 will be given to the second input of the next gate. Here what is the other input? 1 into 1, sorry, 0 1 into 0 0 and the complement will be 1. Here you can observe that the previous state is obtained when we give inputs as 1. So here no change or previous state. Okay, here S equal to 1 R equal to 1, we have got the previous state. Okay, so this is the NAND latch. Now let us see how to make the Verilog code for this NAND latch.